7.3 Enlargements. In this section we consider enlargements. We look at the use of the terms scale factor and center of enlargement. Example 1. The rectangle A, shown below, has been enlarged to give the shapes B, C, and D, also shown here. Write down the scale factor for each enlargement. I've colored them in blue here to make them a little bit more visible. Now hopefully this works. So A is a rectangle. It has 2 units here and 4 units here. Okay, so the rectangle is 2 by 4. 2 width, 4 along the base. And so we want to figure out the enlargement to get to these other shapes. So first of all, to get to B, well, this length is 2, so we've checked B, 1, 2, 3, 4. The similar length in B would be 4. So 4 divided by 2 is 2. So we double 2 to get 4. If this being a similar triangle, we double 4, we should get 8. We have 1, 2, 3, 4, 5, 6, 7, 8, and that is what we get. So this triangle 4 by 8 is double 2 by 4. The lines are double anyway. We'll get into area factor later on. But the scale for A to B is 2. The scale factor is 2. Now let's look at C. Again, we assume that these triangles are similar. So C, this length is 1, this is 2. So here, C is actually smaller than A. C 1, and this is 2, this is 2, and this is 4. So for C, we can actually figure out that 1 divided by 2 gives us a half. The scale factor is actually a half. And then we can check with the base. And 2 divided by 4, again, that is also a half. So they are similar. Let's look at rectangle D. This is 1, 2, 3, 4, 5. Okay, that length is 5. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 divided by 4 will give us the scale factor, and 10 divided by 4 is 2.5. And then we can confirm, just to make sure, 5 divided by 2, and that is also 2.5. So again, the rectangle is similar and has the scale factor of 2.5. Example 2. A rectangle has sides of lengths 2 centimeters and 3 centimeters. It is enlarged with a scale factor of 3. Draw the original rectangle and the enlarged rectangle. Okay, so this grid right here is approximately a 0.5 centimeter grid. So that means that each one of these lines, this length for instance, would be 0.5 centimeters. This line, for instance, that length would be 0.5 centimeters. So to draw 2 centimeters by 3 centimeters, we're going to have to use twice as many of these grids because each one is half a centimeter. So 2 centimeters. To get 2 centimeters on here, we would go, that's half, that's 1, 1.5, and 2. All right, so there's one length. And then to get 3 centimeters, we're going to use 6 of these. And there we go. Not perfect, but pretty close. And that is a rectangle, 2 centimeters by 3 centimeters, roughly to scale. Now, specifically we're talking about enlargements and with scale factor. So what scale factor refers to is a line. It refers to a line. We're not talking about area, we're not talking about volume. So if I had a line here that was of length 1, and I wanted to draw an enlargement here of, say, scale factor of 3, well, I would draw it 3 times as long. So scale factor refers to lines. So this line of length 2 is going to get enlarged by a scale factor of 3. Okay, so we can take 2, multiply it by the scale factor of 3, and we'll get a length of 6. So to draw our next one, we can start right here. We're going to draw a rectangle. This side is going to be 6, and since these are half centimeter squares, we're going to need 12 of them. So 2, 4, 6, 8, 10, and 12. Okay, so it's going to be, the length is going to be 3 times bigger, so it will be a larger rectangle. We'll take up some space. Okay, and the next length here on the original rectangle is 3. And we're going to multiply that 3 by the scale factor of 3 to get a length of 9. And 9 on this is going to be 18 units. 2, 4, 6, 8, 10, 12, 14, 16, 18. Alright, there we go. So now if we complete this rectangle, and comes down to there, and we can draw a rectangle with the dimensions of 6 by 9, and the lengths of these rectangles will each be enlarged by a scale factor of 3. So the lines are each 3 times longer, 2 to 6 and 3 to 9. There we go. Example 3. The diagram shows the triangle ABC. Here it is, ABC, this triangle, and the point O. Okay, right there. Enlarge the triangle with scale factor 3, using O as the center of enlargement. So this should be a new term, center of enlargement. First of all, I've partially redrawn it here. I just want to fill in the triangle. So this is triangle ABC, and there is center of enlargement, point O. So we're going to use a scale factor of 3 to make this triangle bigger. And so we don't just triple each side to make it bigger. We're specifically talking about O as the center of enlargement. So what this means is that's where everything's going to sort of enlarge from, if we can picture that. And I'll do it, and then hopefully we can see what I've done. So from O to C, okay, so we're going to draw the new C, the enlarged C. O to C is 2 points over. If we count 1, 2, okay? But we want to use a scale factor of 3, so we want to multiply 2 by 3 and get 6. So we want to move 6 points over from O. So we go 1, 2, 3, 4, 5, 6. Okay, so this is going to be our new point C for the enlargement. And we actually call that C prime. So we put this up here. This means C prime. Okay, and so we can do this with all the points. B is 1, 2, 3, 4 to the right on the X direction, and 1, 2 up in the Y direction. And we have to multiply those by a scale factor of 3. Okay, so B is over by 4 in this direction, and up by 2. And we want to multiply these by 3 because we're using a scale factor of 3 mentioned in the question. So 4 times 3 will give us 12. We want to move over 12 from O in this direction. And 2 times 3 gives us 6, and we want to move up 6 from O. So starting at O, we go over 12, 2, 4, 6, 8, 10, 12. And then we're going to move up 6, 2, 4, 6. So right here, we have our new B, and we write that down as B prime. B prime. Okay, 4 is over 2 and up 1, 2, 3 from O. Okay, this was B, and now I'm talking about A. A is over 2 and up by 3. So we want to take this, and we again want to use our scale factor of 3. So 2 times 3 is going to give us 6. Moving to the right, and 3 times 3 is going to give us 9, moving up. So to get our new A, we're going to move over 6, that's 2, 4, 6, and then we're going to go up 9. So that's 2, 3, 4, 5, 6, 7, 8, 9. So right here, we're going to have our new A, and that's going to be A prime. Okay, so our enlargements are all just marked with primes. And then we can join these together to have our new triangle, our enlarged triangle, using a scale factor of 3. So that means that each line is 3 times bigger. Okay, so what exactly is center of enlargement, and how can we sort of look at this? Well, what this means is that from O, we've gone, I'll use a different color, from O we've gone and enlarged. It's our center. So things have all sort of enlarged out from O. If you can visualize that, things have all enlarged out from O. Okay, so maybe that's not the easiest to see, but you can picture O as a point, and then you have this triangle ABC, and it gets enlarged by a factor of 3, so obviously it's bigger, but it's enlarging, it's coming out from O, and so you can see, hopefully with this sketch, that it's getting bigger out from O, and hence O is the center of. The following diagrams show two shapes that have been enlarged. Determine the center of enlargement in each case. So here we have one that's already drawn out here, both of them on the same, and here again a second one, two different flags. This is the enlarged image of this one, of course, and here the primes denote the enlargement. And so what we're going to try to do is basically the reverse of this one, where O represented the center of enlargement, and I use these hash marks to sort of show. You can see that C prime and C line up and then come into O. B prime and B line up again together, and with the center, A prime and A line up together and into the center. So they all converge on that center of enlargement. So we're going to try to do this with two examples. So they go between or through A prime and A and then converge somewhere. I'm not really sure. I'm just guessing that it's there for now. But you can draw a line between A prime and A and continue it somewhere, some distance in. And B prime and B, it will go through there and then converge. Looks like I'm pretty close. D prime and D, it will go through and then converge on some center of enlargement. And again, C prime and C does the same thing, goes through. And so they all seem to center right around this point right here. And so that would be our center of enlargement right here for taking this shape and enlarging it to this shape here. And we can do the same thing with our next one, but I need more space because this enlargement point is going to be outside of, just based on, you can tell by the geometry here. So we can label these points first of all if we want to make this easier to read. Perhaps we can call this A prime, the enlargement. That means that this one here, the top would be A, this is the top right. The top right, we could call that B, and then the enlargement would have been B prime. The bottom right C, and the enlargement C prime. This could be a point as well. We won't need it, and we can use the bottom D, and this would be D prime. You could use any point anywhere. These are just some basic, simple, easy to see ones. And so now we're going to do the same thing. So going from A prime through A, it's going to converge somewhere at some point. I'm not totally sure where it's going to be, but I'm going to extend it roughly to there. And also B prime through B, it's going to extend, and that looks something like this. And C prime through C, well, that's just a straight line, so that helps us. We know that it's on this line here. And then D prime through D should get us a point, yes. Okay, so once we've done all four, we can see that they all converge at some point, some center, which is right here. Okay, so that's the origin of the enlargement, to go from this small flag into this larger flag. They all converge into this point right here.